Alright, let me give a little bit more detailed overview of this kiln here. Again, we've got a system where we have forced air burners, so there's no venturi. It's all done via, in this case, a shop vac, pushing air into the burners. Eventually, it's all done manually right now, but eventually my plan is to automate using the temperature controller and an oxygen sensor to control the environment in the kiln. Anyway, the air comes in up at the top here and flows down through the heat exchanger and out through the back. And I've added a lot of insulation blanket here to help increase the preheat temperature. You can see around what used to be the manifold, the bare pipe, I wrapped a bunch of mineral wool insulation to keep everything nice and toasty. If you remember in the last video, it was 450 degree preheat. Right now the preheat is almost 760. So actually just turned. So we've substantially increased the preheat by properly insulating everything here. Again, at the top of the kiln here, move this out of the way. There's about, you can't really tell in the video, it's just too bright in there, but there's about 2 or 3 inches between the top of the kiln where the exhaust is and the bottom of the heat exchanger. It's glowing a nice orange color. It's actually not bright white like the camera shows here. We've also switched to a Type S thermocouple because the last time I ran it up to 2520 it almost melted the Type K, which isn't even supposed to go that hot. So I've switched over to Type S. You can see kind of around here. Here's the manifold from before. Here's the kiln temperature, 2353. Now let me explain a little bit more about these burners. We have in the air flows in through the bottom of this T, and then down here, copper line, that's the propane flows in there. Now that little coupling, it's not really a coupling. I actually, the inlet side of there is actually a 3/8 inch pipe, and I welded an orifice plate on there. And the orifice for this is 28 thousandths of an inch. So that's what keeps the all 4 burners running, equalizes them, even though the inlet propane pipe's a 3/8 inch pipe. So that gives me probably about a max of 200,000 BTU at 30 psi, but I'm not running anywhere near that. I'm actually running maybe 2 to 5 pounds to get it up to 2400 here. So after that, the gas flows in through this tube, and then that's concentric with this other 1-inch tube. The inlet tube is a ½ inch. There's a 1-inch to 3/4 adapter on the end, which just nicely snugly fits, so this ½ inch pipe can actually slide right on in there. And you can't see, of course, inside, but I will show you a picture of the burner, which actually contains quite a few holes and so forth, kind of like they use in a jet engine, where there's different size holes as you run along the burner. Now what that does is it allows me to turn this thing down probably 40 or 50 to 1, so I can actually candle this thing on the lowest setting at about 200 degrees F. And also the other advantage of this burner is that the flame actually doesn't start until it, actually when you first start up in quote jet engine mode, the burner is burning inside, and as you increase the gas flow, eventually the flame comes out of the inside of that inner tube and just burns on as it exits the tube. So it kind of switches between the 2 modes, right, I'd say around 700 or 800 degrees F. After that, then this is just plain mild steel, and what happens is, because the flame isn't actually burning in the tube, it's actually kept cool by the inlet air. In this case now it's preheat temperature, which is below the max working temperature of mild steel, which is around 1,000 degrees. Bottom line is I'm getting super high temperatures out of these mild steel components that you wouldn't think would actually work, but they do work really well. Anyway, that's a more thorough description of the kiln. I hope that helps. I'm hoping that this can be, help motivate somebody to be able to build something like this. But also, running with this heat exchanger on there is very fuel efficient. They can burn, it can go way up, well over cone 10, maybe less than a gallon of propane, which is really pretty good. And the other thing actually about these burners that I really like is they're just dead quiet. So this thing isn't roaring like a rocket engine, it's just sitting here. In fact, you can hear the birds chirping and everything in the background. I don't know if the camera will pick that up. The shop vac actually makes more noise than anything else, which I will eventually replace with a quieter burner. Anyway, this is a more detailed overview of the kiln. I also, if you see over here, I do have the other section of the kiln, so I could eventually build this up one section taller for firing bigger pieces. Anyway, that's the overview. Before I sign out, let's check the temperatures of everything. Right at, let's see if we can get to 2400 here. Oh, maybe not. 23.99. Oh, there it is, the magic 24. That's what I was shooting for today, 24. And before the other thing I want to check here quick is the temperature of the preheat, 798. So that preheat is what gives me significant improvement in the efficiency of this whole system. Anyway, one last shot of the kiln.